This is question 0B part E, understanding spectral leakage. In this question, we're going to repeat the questions from C using n equals to 200. Now we use n equals to 201. You would have realized that when we use n equals to 200, the answers for these spectron lines representing these three terms all land exactly at CK, and there's no such thing as something called spectral leakage. But when we use n equals to 201, these terms especially 0.15 pi and 0.3 pi does not land exactly at integer values of k, and spectral leakage will occur. Alright, now let's visualize the answer when we use n equals to 201. Let's compare the answer when n equals to 201. So basically we are dividing from 2 pi to be 201 for delta naught or omega naught. And in this particular case, the required 0.15 pi as well as 0.3 pi would not land exactly at any integer value of k omega naught. So it will land very close, but it will not land exactly. And in this particular case, since it does not land exactly, the energy representing this exponential here has to be distributed to its neighbor. So you can see that the neighboring terms are not zero now. And let us compare with the previous answer, where in the previous answer all the energy lands at C15 as well as C30 and C minus 30, which is C170. Now, in this particular case, the spectron lines perfectly reconstruct the exponentials because all the energies are going to be retained at these coefficients. In this particular case, since the energy does not completely is being captured at this particular index, its energy must be distributed so that by the conservation of energy, this representation will still reconstruct Yn. So the answer is spectral leakage occurs because we could not get an integer value of k to achieve 0.15 pi or 0.3 pi. How can this be reduced? Well, there are two methods. One of them is by multiplying by a window. So we'll not do this at this cost, but this is what you can do. Or two is to increase the length of the analysis such that n becomes a multiple of period of the waveform. Okay, and when is the next best period? If we are not interested in 201, we can increase up to 240, and when we increase to 240, again this 0.15 pi and 0.3 pi will land exactly at the correct or at an integer k value, and then no spectral leakage will occur. Thank you.